Welcome to the laboratory work demonstration of the magnetic suspension balance. I would like to start with a short overview video of the equipment. So let me just stop here and explain some of the details of our magnetic suspension balance. So first of all, the magnetic suspension balance is here on this part. So we just will go there later. I just explained a little bit more about the periphery of our magnetic suspension balance. We have for the gas moisture content measurements an infrared spectrometer and a dew point meter. The infrared spectrometer has to be calibrated before the measurement, and we just do it in a 2-point calibration. One point is the 0 point and the other one is moisture value where we know that we just stay below this value. So then we just have the two limits of our drying process. What can we see further? Here is the display and the value from the magnetic suspension balance. Then we have some temperature signals, and all our signals were just recorded and visualized by a computer, and we just receive after each measurement an Excel file where we just have for every 2 seconds a value. So maybe we just go now a little bit more to the left side. Okay, so how we arrange different kind of gas moisture conditions for drying process. So we have a gas mixing unit. This is here where we can mix completely dry air with completely wetted air, so we can arrange any relative humidity between 0 and 100%. All the mass flow of the drying gas is also controlled by mass flow controller, so this is also really precise. And now we just come finally to the magnetic suspension balance part. So let me just stop one more time here. The balance is just in this house on the top, and then we have a coupling house. This is this part, and finally below the coupling house there's our actual drying chamber. So this is right now here, and after we have placed later our sample holder with our material, we will just close the chamber, and then the drying experiment can start. So but let me explain a little bit more how the magnetic suspension balance is working and why we have so much things around it. So first of all, the balance is here, and the balance has an electromagnet which is placed below it. We can't see it, it's in the housing, and the electromagnet can change by a controlling system the power. And in the coupling house we have a permanent magnet which is lifted up by the change of the power of the electromagnet, and the system is working in this way that the permanent magnet, including the connection rod, which we can see here, is levitate in always the same position, and it's contact free, so we don't have any thermal influence of our drying process to the magnetic suspension balance, or to the to the balance itself. So, and for this we have isolated the top part, and we have also isolated the coupling house, and we keep the temperature here above constant, around 50 degree, and the rest of our device we can go up to higher drying conditions over several hundred degree. And for this we just have to keep this temperature constant to avoid any thermal influence to our balance. So now we just zoom a little bit more in, and we can see that the sample holder is rotating a little bit. So this is the indicator that it's contact free. Yeah, it is can rotate without any contact. So maybe we just, or I just explain a little bit about the for what kind of measurements we use the magnetic suspension balance. We are able to analyze drying kinetics of single particles, and particles that we dry in the magnetic suspension balance or in the drying chamber are surrounded with conditioned air. So as I said, we can control the temperature and also the moisture content of this air, and also the change of the drying process is recorded as we just measure the outlet moisture content of the gas. And of course we just recorded the changes in the weight. So this is then an indicator for the water loss of our particle. And the work field of our balance, it's like we can take samples from 0 to 8 gram, and the resolution is 1 microgram, which is really good. And the temperatures are actually below 0 up to 120, or we can even go up to 200. So this is a little bit better than we just have shown here. So now I would like to show you how we just applicate a single particle that we have wetted before. So you can see in the glass some particles that we have wetted, and we just put one of these particles in our sample holder. We have different kind of sample holders for that. Right now it's a mesh or a small basket of wire net. So, but later I will just show you some more of our sample holders that we have. So I just put one wetted particle there, and now I just show how we just applicate this sample holder to the magnetic suspension balance. For that, the camera has to zoom a little bit more out, and yeah, we just take it carefully as the system was quite sensitive. So you have to have a really quiet hand, and you can see it is rotating. So this is the indicator that the permanent magnet is levitate in the correct way. The camera has some focusing problem, but yeah, we have already seen that the sample holder is in its place. So yeah, once more the single particle which is just stored in this sample holder. And yeah, now I just close the drying chamber, so then the particle is just surrounded by the conditioned air, and the drying process can start, and we just recorded the drying kinetic of one single particle. So, and finally, I just would like to show you the different sample holders that we have. So I'll just make one camera move. Just stop here, and so we have different sample holders. So you see, you can see this on the left one. This is kind of small cups where we can dry a small amount of powders. Then we have these grid meshes here for single bigger particles, and we have also these wire sling where we just can fix one particle, and then the particle is just completely surrounded by the gas flow, and no let's say no influence of the mesh or the form of the mesh is given in this kind of sample holder. So this was our magnetic suspension balance. Thank you for your attention.